Okay, so first thing we do here is look at the graph of sine of x. And when we're thinking about the graph of sine of x, the first thing to do here is we'll start by going around the unit circle and thinking about the y value. Now this is just the y value, 0, 1/2, root 2 over 2. And we get up here to 1. And then we're going to go back down, root 3 over 2, root 2 over 2, and then 1 over 2, back to 0. And then at this point, the sign becomes negative. So negative 1/2, negative root 2 over 2, negative root 3 over 2, and then negative 1. And then it's also still negative, but as you see, it's getting closer back to 0 until we're back to 0 here. And then it's just going to keep going back around. But this is one phase, right? This is one period, right? And so those values for sine are going to be the y values on our coordinate plane. So as we see, it went from 0 all the way up to 1 before it then went down. So we'll say the amplitude here, or the highest point, the max value will be 1, and then the lowest value was negative 1. So those are our values on the y-axis. The x values we'll take from the angles. So this angle was pi over 6, and then we had pi over 4, and then pi over 3, and then pi over 2, and then we had 2 pi over 3, and 3 pi over 4, and then we had 5 pi over 6, and then pi here. And we'll continue, 7 pi over 6, and then we had so 4/4, 5/4, so 5 pi over 4, and then this would be 4 pi over 3, and then 3 pi over 2, and then we'll come back over here, and this would be 5 pi over 3, 7 pi over 4, and 11 pi over 6. And then back to 2 pi. So that's going to be our graph here, right? And we'll put 2 pi way out here. And we're really only going to care about these kind of 4 quadrantals, right? So this is pi over 2, pi, 3 pi over 2, and 2 pi. So this here halfway is pi. Halfway between there is pi over 2. And then 3 pi over 2. And if we were to go backwards, this would be negative pi. Right? So we can do the same thing here, right? Negative 2 pi, negative pi, negative pi over 2, and negative 3 pi over 2. Okay, and those are just kind of our points, and we see here if we went backwards, it'd be negative 1. So let's look at what that graph kind of looks like. Let's change colors here. Let's go to purple. So at 0, when the angle is 0, our y value is 0. When we get to pi over 2, our y value is 1. When we get to pi, we're back down to 0. When we get to 3 pi, we're down to negative 1. And when we get to 2 pi, we're back to 0. So our graph will kind of look like this. All right. So as x gets larger, y increases, and then it decreases. So here's that first half of the circle. At this point it becomes negative. So for these x values, y was negative till we got back to 0. So between pi and 2 pi, sine is negative, which is why the graph is down here. If we were to go backwards, right, so negative, right, because this is coterminal. 3 pi over 2 is coterminal with negative pi over 2. So at that point, it was negative 1. And then we keep going, and it's negative until we get to negative pi when it reaches 0. And then negative 3 pi over 2 is actually a positive 1. And then negative 2 pi is back to 0. So here we actually see 2 full periods of the sine function. And you see how if we just keep going around in the circle, it's just going to keep repeating that rise and fall, rise and fall, rise and fall. So that's the sine function. Now, if we were to talk about its inverse, which is cosecant of x. The cosecant of x just takes the reciprocal of all of these points. So the reciprocal, right, anytime sine is 0, right, anytime sine is 0 here and here, the reciprocal of 0 is undefined. It doesn't make sense because 0 would be in the denominator. So I can throw an asymptote in here and in here. So let's talk about the reciprocal of 1/2. Reciprocal of 1/2 is 2. So at 1/2, so at pi over 6, we're going to be at 2. And then at pi over 4, the reciprocal of that would be 2 root 2 over 2. So it's getting smaller, getting closer to 1, getting closer to 1. When we get to pi over 2, the reciprocal of 1 is 1. And then as we go this way, we're getting back closer to being to here, which is 2, so it's going to keep rising. And then as we get closer to undefined, it would be undefined. So there is the graph of cosecant. And then when we get here, it becomes negative. So the reciprocal of a negative function is still going to be negative. The reciprocal of negative 1/2 is negative 2. And then it gets closer and closer to 1, like we were seeing before, until it actually becomes 1. And then it moves away from 1, getting larger and larger until it becomes undefined. And there we see the cosecant function, and it would exist the same way over here. So it just keeps going in this manner. So we have sine, and we have cosecant, and those graphs are reciprocal graphs of each other. And just remember that the asymptotes exist for the cosecant, where sine equals 0. You will have an asymptote for cosecant. So let's go down here. We'll start all over. We'll talk about the graph for cosine. So now we're looking at y equals cosine of x. So cosine starts at 1, and then it gets smaller. I go to root 3 over 2, root 2 over 2, then 1/2, and then it gets to 0, and then it becomes negative. Until it gets to negative 1, and then it stays negative, but it's moving in the direction back towards 0, and then it's positive again as it moves towards one. So if we think about that, right? Our largest value is 1. Our minimum value is -1. Again, we'll think about 2 pi. We'll think about pi over 2, and 3 pi over 2. And we can go backwards again. -2 pi, -pi, -3 over 2 pi, and pi over 2, -pi over 2. So again, if we're following this graph, right, we will see that it starts here. When the angle is 0, cosine is 1. And then as I go, right, as x increases, as the angle increases, we get closer and closer to 0 until we get to here, which is 0. And then it goes negative all the way down to -1 at pi. Then it gets back to 0, right, at 3 pi over 2, and then moves up to 1 again at 2 pi. So let's just take a look at, make a little better graph here. And there's that. Now again, if we were to go backwards, right, it starts at 1 and goes down towards 0. And then it becomes negative all the way down to -1 at -pi. And then it's negative, but it's moving towards 0 at -3 pi. And then it's positive again back up to 1 at -2 pi. So we follow that down. And there is our cosine function. And it follows naturally around the unit circle, so that's why that unit circle is so important. But then we can also talk about, just like we did with the reciprocal of sine, we did cosecant, we can do the reciprocal of cosine, which is y over secant of x. And just like the reciprocal of sine had asymptotes at its value of 0, cosine, whenever cosine is 0, its reciprocal, secant, will have an asymptote. So that happens here at -3 pi over 2, at -pi over 2, at pi over 2, and at +3 pi over 2. And just like this, the cosecant function, its graph, the secant function, will look just like the reciprocal of this graph. And the green is the graph of the secant function. Okay, so you need to be able to graph all of those things. All right? And we're now going to move down here and talk a little bit about y equals tangent of x. Okay, so we'll look at the graph of y equals tan of x. So again, we'll look at the graph first. So again, tangent here will be 0, and then we have √3 over 2, and then here we have 1, and then we have, or not √3 over 2, √3 over 3, and then we have √3, and then up here we have undefined, and then we're going to go back down to negative √3, -1, negative √3 over 3, and then back to 0. And then as we come through here, it's going to climb back up and it'll be positive. So √3 over 3, 1, √3, then undefined, and then it becomes negative again. So negative √3, -1, negative √3 over 3. So remember tangent, right? Remember that tangent is equal to sine over cosine, or y over x. So if we think about our quadrants, right? Our quadrants, this is a positive positive, this is a negative positive, this is a negative negative, and then down here we have positive negative. So that makes sense that tangent, right? If we have positive over positive, that's positive. A negative over a positive is a positive. I'm sorry. Positive over negative is a negative. Negative over negative is a positive. And then positive over negative is a negative. So that's why tangent goes from positive to negative to positive to negative to positive to negative, right? And notice that as we go through here, it just keeps going from small all the way up to undefined. So if we're starting here, there isn't really a highest value here, right? There's no maximum value for the y. So when we're looking at the axis here, we'll still think about, we actually will complete a full cycle at pi and negative pi. And then we can go over here to 2 pi. If we want to continue with those, so pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and negative 2 pi. So again, our asymptotes will exist here when it is undefined. So that exists at pi over 2 and 3 pi over 2. It would also exist at negative pi over 2 and negative 3 pi over 2. So at 0 we have 0, and then at halfway we're at 1, and then it's just going to keep going up. At negative halfway, right, at negative pi over 4, we're at negative 1, and then goes down forever. So that's what the tangent function will look like in a graph form. And notice it takes until it gets back to this spot. This is just a repeat of the first graph. So this, to get from here to here, is actually means the period here equals pi. It only takes pi for the tangent function to complete one full cycle, which is different, of course, than what it was for sine and cosine, which was 2 pi. And hopefully this helps you to see why the period for tangent is only pi. It takes one round to get back to the original starting point, and then it just repeats itself. So 2 full rotations, 2 full periods within 2 pi. Alright, and that's the graph of tangent. And if we were to do cotangent, right, cotangent is just going to be the reciprocal of all of these. Again, reciprocal of 0 is undefined. And this was 1 over 0, so the reciprocal of that would be 0. So this all just kind of changes, and we have a asymptote here, and an asymptote here, and an asymptote here, right? And its positive negative aspects stay the same. So on this first phase, it's going to be negative. So you can see here's kind of the rotation where it goes through for here. So it's undefined, and then it's up here at root 3, right? And then it comes down to 1. So it's up here, comes down to 1, then it comes down to 0, and then it becomes negative. So it kind of has this here. And so the cotangent is just the reciprocal and just cycles down that way. I messed that one up. I don't have my asymptote here. So the cotangent would look something like that. Okay, so, and that, again, that is the graph of y equals cotangent of x. Alright, so those are all the graphs with no types of shifts or amplitude changes or period changes. The next thing we'll look at will be changes to the graph themselves.